All right, so what's happening here? Stop with all the messages. So as a warm-up today, I'm going to make up another one like this with an odd number. So we're going to go x squared plus 17x minus 9. Uh-oh, this is going to be interesting. Okay, now what? If we're doing completing the square, we add 9 over to the other side and we add blanks. Okay, then what's the pattern? Good job. In the parenthesis goes what? Nicely done. Okay. Then back here we have to square it. Does anybody know 17 squared? I think it's 289. And the bottom, don't forget to square that too, right? Somebody checking me on the 289? Yes. Okay. And then over here we need to add 9. So we'd type 9 plus 289 divided by 4. Math, enter, enter. All right, next step. Square root both sides. And anytime we square root something with an x, we're going to remember to put a plus or minus over here. The square root of 325 isn't going to be exact, but is there something that divides in there? 5's not a perfect square, though. 25 goes in there how many times? How many? 13. So we would have 5 square roots of 13. Everybody okay with that? Simplifying radical? All right. In the denominator, though, remember the joyous thing is that the square root of 4 is 2, so we no longer have to worry about a radical down there. And then the last step is we need to subtract this over to the other side. Okay. One kind of like that on the quiz. Any questions? All right. Factoring. Were we okay on factoring? What about quadratic? Did we do all 3 of these yesterday or did we run out of time? We did all 3? Okay. And we talked about simplifying appropriately. Did we do all 3 of these? Okay, so let's just finish up with this last question. Do you remember what the discriminant is? It's going to say on the quiz, the discriminant formula is, and you're going to write what in that blank? Nice. And you're not going to put a square root over it, right? Okay. And so in this, we have A is 2, B is negative 12, and C is 18. So the B squared minus 4 times the A times the C. This is 144. Yep, don't know. Is it 144? Might be. So we get 0. So think about quadratic formula. If I did opposite of B plus or minus 0 over 2A, how many solutions would I get?
1.
Only 1. So it has 1 unique real solution. Okay? How many of you worked on worksheet 2A, the evens last night? Good job. Wow, not too many. Okay, so you have plenty to do if you don't do too much work on the pretest today, is what you're telling me? All right, I am going to go ahead and talk about complex numbers for just a minute. I'm not going to do all of the different things today. Okay, what time do we start? Around 25? So by quarter till, make sure I stop talking and hand out the pretest, okay? Complex numbers are, I think I have a slide. Let me start over. Okay, Your learning targets on this are going to be able to add and subtract them. Super easy. You can rationalize complex number using a conjugate. Okay, that's a little more complicated, and powers of I students sometimes struggle with. Now, let me give you the bad news about this. Some of you learned to do these in Algebra 2 by putting your calculator in A plus BI mode. You're not going to be able to use the graphing calculators for this quiz. I will have some scientific calculators, or you can bring your own scientific calculator, but I need you to show me that you can do this without the calculator, and I need you to show me that you can do quadratic formula without access to any programs. So that's why we're doing this quiz with only a scientific calculator. There's a couple quizzes we do that with this year, not very many. And I will have some. All right, powers of I, we're going to talk about Monday. That's too much fun for today. Okay, so complex numbers, there's all the real numbers, then there's imaginary numbers over here, and complex numbers are when you have things like 3 plus 2i. That's considered complex because it has a real part and imaginary part, okay? I'm not going to quiz you on that, but that's the vocabulary. What's the definition of I before we get into this any further? Anybody know? Do you remember from last year? Square root of -1. So anytime we have a square root of a negative number, we're going to write it in terms of I. All right, all I want to talk about today is adding, subtracting, multiplying these. So the thing that's going to happen is when you square both sides, what will you get on this right side? When you square a -1, you get square root of -1, you get -1. So this is the trade we have to watch for on some of the problems today. All right, so this first one, all I do is combine like terms and I treat the I like a variable. So what would I get? It says plus here, so I'm not foiling. Somehow this shows up on a quiz and people think they should multiply. So I'd have 5 minus 2 is 3. And this would be plus 1i or just I. Okay. The second one, they're trying to slide something past us. Don't forget you got to distribute the negative. I always rewrite it so I don't do something silly on a quiz and have to do a retake. Minus negative would be plus, right? Now combine your like terms and you get what? Plus 4i. Now, if you wrote 4i minus 4, I wouldn't count it wrong. But the proper form for any complex number is real plus or minus the imaginary part, okay? I'm not picky, but just letting you know. All right, so let's multiply, which means we're going to FOIL these together. So 2 times 7 is 14. Then I'm going to distribute the 2 back to this, would be a negative 8i. In the middle, if I'm distributing the negative 3i to the 7, I'd get what? Negative 21i. And negative 3i times negative 4i would be positive 12i squared. All right, what is I squared again? So if I replace that with a times -1, this whole 12 becomes what? Minus 12. So now if I combine like terms, I have a 14 and a minus 12 is 2. And these two together make a minus 29i. How did I do? Anybody? Did I make any little mistakes? Okay, can you try this one? Just FOIL this together and see what you get. Anybody get an answer? I got 41. 4 times 4 is 16. Minus 20i and plus 20i, those divided out. But make sure this was a minus 25i squared, so then it became, when you replace the I squared with negative 1, right? Became positive 25, which if I added right is 41. All right, very important thing we're going to need to practice more on Monday is that these got rid of imaginary, right? There was no imaginary after we simplified. That's because these are what are called conjugates. The conjugate of a plus bi is always a minus bi. You keep the real part the same sign and you change the sign on the imaginary part. So we use conjugates to do, I'm going to make up an example here because I'm not going to do more of these today. I'm going to wait till Monday to do more, but I'm going to do one. Okay, here's my example. Use a conjugate to get rid of the I in the denominator. Because that same evil mathematician who wrote all those other stupid rules said you can't have... Okay. Okay. All right. So we can't have i's in the denominator because it's really a radical. So we have to get rid of it. And to get rid of it, I can't square it. Because if I did 7 minus 2i times 7 minus 2i, I'd get 49 minus 14i minus another 14i plus 4i squared. This would not go away, right? So squaring it doesn't do us any good. Besides which, you can't randomly square the top and bottom of a number unless you have an equal sign and square the other side, blah, blah, blah. What's the only thing we're allowed to multiply by? It will not change a number. 1. So we're going to multiply this by a form of 1 that will get rid of the I down here. We're going to use the conjugate. What is the conjugate of 7 minus 2i? Okay. Now, that looks really nasty, and it kind of is. So we have to FOIL the top together and FOIL the bottom together. But what should happen on the bottom is there should be no more I, right? Okay. So tell me what you get on the top when you FOIL those together. 4 times 7, 4 times 2i, I times 7, 2i times I. We'll deal with that in a second. Okay, in the denominator, 7 times 7, 7 times 2i, if I could write, negative 2i times 7, and negative 2i times 2i. Okay, what's left on the top? What does 2i squared become? Negative 2. So then 28 and negative 2 is 26 plus 15i, is that right? And in the denominator, this is gone. What does minus 4i become? Positive 4, so I get 53. Okay, now I would accept that answer, honestly, but does anybody know what it would look like to be in proper a plus bi form? You need to separate it so it would say this is my a plus this is my b times I. Ugh. Okay, yeah, I would take that form right there. Okay, but you can't leave it like this. It can't have an I in the denominator. All right, enough for today. So you should have picked up at the door a worksheet that has the book assignment on it, because we're short books, so rather than give half of you a book, I just went ahead and printed the book assignment for you, okay? It's kind of hard to read, but the assigned problems, did I circle them? That would have been really nice for me. Okay, I think the problems are circled. Otherwise, it should be on the blue sheet. Let me stop my recording here.